What's going on, coders, and welcome to episode 9 of our Pandas playlist. Now, I hope you're just as excited as I am for this episode because we're going to be covering how to visualize your data. And in terms of data science or data analysis, visualizing your data can be just as important in understanding that data as, say, performing some mathematical or statistical analysis on it. And to be quite honest, it's a lot more fun too when you get to create pretty graphs and really nice looking diagrams that can really put an emphasis on the type of analysis that you're trying to make to your audience. Alright, so there are actually so many ways that you can create visual diagrams using Python. It would take weeks, even months, of a continuous live stream to go over every single library and unique way of creating these graphs. However, we're just going to try to keep it as to the point and succinct as possible in this episode, and we're going to just cover one method, and it's off the Pandas module, and it is called easily plot. So let's jump into the code and see how to use this method. Okie doke, so let's say that you want to put your economist hat on for the day and analyze some inflation data within the United States. So you would go to one of the most popular websites for economic data within the US, which is the FRED database, and then you would look up this table right here, Consumer Price Index for all urban consumers, all items less food, yada yada yada. And if you have no idea what any of this economic jargon means, then don't worry. This is basically what we say as inflation. This is the economist's equivalent of our inflation. All right, so what I did is that I downloaded the CSV for this data set. Then I uploaded it into my GitHub, and this is the raw file for that same data set. Looks like, again, just a cursory overlook. We have two columns, one for date, one for CPIL, FESL. Again, that is inflation. All right, so the first thing that we're going to do is import pandas as PD. Now, if you aren't using Jupyter, like Jupyter Lab or Jupyter Notebook, and you're just running this on a normal Python IDE, such as Sublime or VS Code, then you'll need to use matplotlib.pyplot interface to see your plots. And that is one of the cool things about using Jupyter, actually. As you can see, again, we are in our Jupyter lab. What Jupyter does is that it will automatically show you your plot or your diagram after you have created it. However, you don't get that same cool feature in just a normal Python IDE. You're going to have to utilize some other interface, such as the matplotlib.pyplot interface, to see those diagrams and graphs that you have just created. So again, if you are using just a Python IDE, then you'll first need to pip install matplotlib. And then you'll need to import matplotlib.pyplot as PLT, or whatever you want to call it. And you can do that maybe right after your pandas import statement. And then at the very end of your code, you're going to need to call this .show method on your plot to actually see the graphs which you, again, have created. However, and by the way, if you are using Jupyter, you can run this step too if you want to. In fact, there are a lot of additional features that you get from matplotlib that you don't get just from the normal pandas plot method. However, we're trying to keep, again, this episode as clean and as streamlined as possible, so we're not going to actually use matplotlib in this episode. Alright, so I'm going to import pandas as PD, and then we're going to, after doing that, we're going to read in our CSVs, which we're going to use for today, and convert them into data frames. Now, this first CSV that we're reading in should look very familiar to you. This is our students data frame, which we've been using, I think, quite literally for every single episode of this playlist so far. So if this doesn't look at all remotely familiar, then that tells me you haven't been watching any of the episodes of this playlist. However, if it does, then good job, you're all on track. And then the second data frame which we're going to be analyzing is that CPI, that inflation data frame, which I just showed you right over here. Cool, so I'm going to read that in, and we're going to take a quick look at it. Again, here are our two columns, one for date, one for CPI. Again, CPI is basically inflation. All right, so, or it's a measure of inflation at least. All right, so let's say that we wanted to now graph this. We want to take a look at how this was trending over time. How could we graph this data and not just look at raw text and numbers? To graph it, we're going to use the dot plot method. It says literally it's as simple as that. All it takes to see a nice graph is to call dot plot on a data frame or a series. So let's take a look at that. If we call dot plot on our CPI data frame, let's see what we get. Booyah! Just like that, we now have a really cool plot that just showed up out of the blue. All for calling dot plot. We didn't add any optional arguments or anything like that. It just showed up just like this, and it looks actually pretty clean. It's already kind of looking similar to what we see in this professional plot right here, right? Awesome. So as cool as this is already, there is a lot of work that we can do. For starters, when you just call dot plot and don't add anything into the arguments, or don't add any arguments, then it's just going to take a lot of default parameters, right? One of those defaults is that the x-axis is going to be defined by default by the index of your data frame. And most data frames have just an index that ranges from 0 to however many rows minus 1 that you have in your data frame. So that's not really that much help for us, right? We don't really just want to see the numbers 0 through 800 displayed across the x-axis. What we want as an x-axis is this date column, right? We want to see how CPI is trending over these dates. So the way to specify the data for your x-axis is to use this argument name right here, this argument x equals. So let's do that right down here. So again, we can specify data for the x and y axis. Let's do it first for the x-axis, and if we call dot plot with x equal to date, which is our column name that we want to specify or that we want to use, then now we get the dates as our x-axis. Now, granted, it looks like they're all bunched together. We'll fix that in just a second. But now, Pandas is using date as the x-axis, which is pretty dang cool, if you ask me. All right, again, we can also specify something for the y-axis. Again, this is by default. Pandas will just basically take whatever numerical values it has, whatever numerical columns it has. There's only one. So just saying something like y equals this column right here is not really going to do much for us because that was already the default. But that is just, again, another way of specifying what you want your y-axis to be. Awesome. So let's move on a little bit more to clean up some more stuff. So the first thing that I want to show is that when we are calling this dot plot method, you can see our plot right here. However, we also get this output right here. This is Jupyter Lab output right here. If we want to actually suppress this, then we can use a cool trick in Jupyter Lab, and that is to add a semicolon to hide any IPython text output. So if we do that same call, basically, if we call this same dot plot method with x equal to date, then now we don't get that text output that we saw up here, right? And that is because we suppressed it using this semicolon. So that's just a neat trick that's good to know. All right, so that's what we're actually going to append to every single one of our plots from now on. Cool, so the next thing we're going to do is change the display size. Because as you can see, our x-axis labels are all bunched together, and quite honestly, this is a bit of a small graph, especially for people who are hard of seeing, right? So to change the display size of the graph, you need to utilize this optional argument fig size. So fig size takes in a tuple, which is just basically two different numbers surrounded by parentheses. The first number is going to be your width in inches, and then the second is going to be your height in inches. So again, these are kind of arbitrary, but if you said a ratio of 15 width to 6 height, then what that's going to showcase now is a nice looking graph, and it's nice and spread out. These x-axis labels aren't bunched together anymore, and now we can see a little bit better. We can see a larger graph, which is better on the eyes, better on our eyes. Cool, so that is how to change the size of the graph. There's a couple more things. Let's now add a title and an axis labels. As we can see, we have no title in our graph right now. We have one axis label right here, date, but we can actually change that. And then we have no y-axis label. So what I'm going to do is call x equals date. Again, y is going to be our CPI data right here. Our title, I'm going to give it this title as a string. The label is actually, so what I mean by label is I'm actually going to change this label right here, the legend label. I'm going to change that to USA. Our x-axis now is going to be x label equals date. Our y-axis is going to be y label equals CPI without food and energy. And then our figure size is going to remain the same. So let me run this right here and see what we get. All right, so now we have again a nice title right here. Our x-axis label has been changed to date with an uppercase D and lowercase 3 letters after that. We now have a y-axis label, and our line has a new label. In the legend, it is notified, or it is labeled as USA. Cool, so that is some quick fixes, or that's some cool little adjustments that we can make. Now let's format our graph even more by adding a line width, a line color, by hiding the legend, by adding a grid, and by changing the axis font size, the axis label's font size. Cool, so if I run this now, we can see that we have indeed increased the width of the line. We have given it a reddish color because red is bad, right? Usually inflation rising this quickly is not good. And then we have also gotten rid of the legend. We have added a grid. And we have changed these. Now these axis numbers are a lot bigger, right? If we changed it to like 23, then that would be even bigger than that. But I think 13 is a good size for this graph. Awesome, so that is just a couple of things. Again, there are a lot more arguments that you can add, but we don't have the time to cover them all in this episode. And again, if you do import matplotlib and start using the methods off of this pyplot, then you have even more things that you can change about it. And again, the list doesn't end just right here. Cool. So just for fun, let's add also a regression line to this cool CPI line right here, all this data. Again, this is optional. I just like to do this because it is kind of fun and it's more data science-y. So what I'm going to do is actually create a regression line using NumPy. I'm going to use the polyfit method on that. And then I'm going to give that regression line as a new column, and I'm going to plot it. So let me just run this again. All this is optional. I'm just running it because it's kind of cool. So here we go. So now we have our regression line, and this is a regression line of degree 2. You can't really see the bend in this regression line. I guess if you look really closely, you can kind of see it, but yeah, this is more of a curved regression line. Awesome. So again, I just want to do that just because it's kind of cool. All right, and it also showcases that we can add more than one line on a single graph. Awesome. Cool, so plotting, all that we've been plotting so far is basically just a line, right? That is the default for the .plot pandas method. However, sometimes it doesn't really make sense to have a line graph for every single graph that you want. So let's say that we were trying to find maybe like the correlation of our math score with our reading score on our student's data frame. Again, just for a quick review, looks like these are just a bunch of numbers for a bunch of students that have taken some standardized test. Again, all of this is fictional data, but yeah, that is what the math score and reading score is. Let's say that we want to see if there is some correlation between the two. So we would plot math score on the x-axis and reading score on the y-axis. If I run this, then this is the plot that we get. Now this is not pretty at all, right? I have no idea what this is other than just a big scribble that maybe some third grader did, right? So this is not very professional looking at all. However, it is technically a line graph, right? Basically what it's doing is it's taking point to point to point to point to point to point to point and literally drawing a line in between them all. However, that's not really what we want. So to change from a line graph to something more suitable, such as maybe like a scatter plot, then we would need to change the kind optional argument. So let's change it from the default, which is line, to scatter. And if we do this now, then there we go. Now we have a much better looking, more professional graph. It's literally just plotting all of the points, but no lines in between them. Cool, so this definitely works, and this is completely fine to do. However, if you wanted, I guess, maybe more of a shorthand for a scatter plot, what you could do is instead of saying dot plot and then adding your x and y optional arguments and stuff like that and saying kind equals scatter, you could just say dot plot dot scatter and then add whatever optional arguments you were going to add into your dot plot method. So again, it's just one additional step, but it does, I guess, save some keystrokes on typing out kind equals, right? So if I were to run this, we get the same exact graph. So again, that's just another way of doing the exact same thing. All right, so scatter plots are one of the plots that you can create. You can also create bar plots, right, or bar charts. So let's say that we wanted to find maybe the reading score grouped by, or the average reading score based on gender. All right, that seems like a pretty good bar chart to make. So if I were to run this, here we go. So now we have the average reading score for our fictional database based on gender. And it looks like the females are dominating the males just by a little bit, but this is definitely, the important thing is that this is a bar chart. Again, you can do the same exact thing by calling plot.bar, just like how we did with plot.scatter. And just to verify that, again, yep, we get the same exact output. Cool, so we can also do histograms. Let's say that we want to find, or we want to just plot the math scores in a histogram. Looks like we have a little bit of a left skew with our math scores, but that's pretty expected, I suppose. There's a stop at 100, and it looks like the average is a little bit closer to 100 than it is to 0. All right, again, we can just do plot.history. I'm not going to run that because I'm already 100% sure that it's going to be the same exact output. All right, so then we can also do pi. This is the last one that I'm going to showcase. However, as you can see, there are a ton of different plots that you can make with pandas.plot. You can make a bar H, which is horizontal bar plot, a box plot, a kernel density estimation plot, an area, scatter, hex bin, all of these different plots that you can make, and I would suggest and encourage you to experiment with. Cool, so let's showcase just one more again, which is the pi plot. Let's say that we want to find the number of students by race, ethnicity who took our examination. And we want to plot that in a pie plot. So there we go. We have now our pie chart right here. Looks like the majority of our students were Asian American, and then the least amount of students were white American. Awesome. So again, this will work the exact same way if we run just plot.py, just like this. Cool. All right, so that's going to be it for this episode. Again, this barely scratches the surface of all the data visualization techniques that you can do in data science, data analysis, pandas, anything like that. However, I think this is a very good introduction to just get started, and then you can definitely start playing around even more if you wanted to. Don't forget to write any comments or questions down in the comments section below. I'd be happy to answer them. But for now, again, I hope you enjoyed this one. I hope you learned something from it. If you did, don't forget to hit that like and subscribe button, and I'll see you in that very next episode. See ya, gang.